Hello, welcome back to the channel. So let's do one more question which is based on the graphical representation version of comparison test in this case. So in this question, you have to decide whether the following statement which is provided in this question is true or false. And also in addition to everything else, if this statement is false, we also have to provide a counter example which proves that the statement is false. So now since in this question we know that f of x and g of x are continuous functions, so there is no breakpoint for the curves, right? So now based on this condition we have to check whether this statement is true or false. And the statement is if the area under the curve of f of x dx from x equals 1 to x equals infinity converges, and we know that this fact is true, that the g of x function is always greater than equal to f of x is always greater than equal to 0 for all values of x, then our g of x dx also converges. So we have to prove or disprove this statement over here. So let's consider two arbitrary functions f of x and g of x and sketch them on a graph. So if we assume this is the graph of our function, this is the y-axis and this is the x-axis. So let's assume, since we know that g of x is always greater than equal to f of x and both of these graphs are greater than equal to 0, so both of these graphs lie above the x-axis. And now based on this given information, let's sketch the graph of both of these functions. So let's assume this is f of x and since we know that g of x is always greater than equal to f of x, we know that our g of x function will always be above the f of x function, right? So let's assume this is our g of x function over here, right? So this curve over here is for f of x and this curve over here is for g of x, which satisfies this condition over here, that g of x is always greater than equal to f of x and both of these graphs lie above the x-axis. So that is why both of these values, y values, are greater than equal to 0 for all the x in the interval, right? And since there is no breakpoint in the graphs of both of these functions, they are also continuous functions. So now we know that this is the graph of f of x and this is the graph of g of x, right? And now based on this graphical representation, we have to check whether this integral converges if this integral also converges. So since the integral is from 1 to infinity, let's suppose this is our x equals 1 point. So now this integral over here is basically this area under the curve, right? So fx dx integral from x equals 1 to x equals infinity is this area over here, right? And we know that this integral converges. So we know that this area has a real solution. This area under the curve for f of x dx has a real solution to it. And now based on this condition, we have to check whether this area over here, the area of g of x dx, which also includes the area under the curve for f of x, will converge or diverge. So now you know that based on this given information, if we know that this area under the curve has a real solution to it, we cannot necessarily state that this g of x dx integral or the area under the curve for g of x will also converge, right? So this statement becomes false because this statement is not necessarily always true, right? Because since we know that the area under the curve for g of x is greater than f of x, so the area under the curve for g of x can also approach infinity, right? So that is why we cannot necessarily state that the g of x dx area would also converge. So this statement is false. So now since this statement is false, we also have to provide a counter example which disproves this statement over here. And an easy counter example can also be found on the solution to this problem. So first of all, we stated that the condition, the statement given in this question is false, and that is because we know that if the area under the curve of f of x is finite, which means if this area under the curve has a real solution, the area under the curve for g of x, which is this one, could be much larger and even infinitely larger, which will make the definite integral to diverge, right? And an example which disproves the statement above is these two functions. So if we assume our f of x to be e to the power minus x and g of x to be 1, we know that since the exponential function is positive and 1 is also positive, so they are always greater than or equal to 0. And we also know that this integral, the integral of f of x dx from x equals 1 to x equals infinity converges, and that is what we already proved in the last videos as well. We know that this integral converges, but if our second function is 1, this function diverges. If you'll calculate the integral of 1 dx from x equals 1 to infinity, it will be basically limit r approaches to infinity of x with the endpoints r and 1, right? And then if you'll take the limit of r approaches to infinity, this would be r minus 1, and then if we'll take this limit, it will approach infinity, right? So this integral diverges. But now, since we satisfy this criteria over here and also this criteria, we are not able to satisfy this criteria over here, right? So that is why this example serves as a counter example to disprove this statement over here. So that's it for this video. This question was another version of using comparison test in order to prove or disprove statements. So feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.